All right, here we go. I'm ending, sorry. All right, so 1/20th was the correct answer. 1/20th was the correct answer there. Now, got some different answers there. Let's talk about how this works because, like I said, this should be something that stop please. We should be pretty good at this, okay, by now. What are all percentages a fraction out of? Yeah, 100. So when we do 5 out of 100, now we can just simplify it. Now, I know a lot of you are probably doing the calculator way, which I guess is okay because that's the way you were taught when I was out. But when you look at this right here, what factor does 5 and 100 share? Kyle?
That they both have 5.
They both have a factor of 5. So basically, I can divide both the top and bottom by 5, and that's what I'm going to get 1/20th. Now, you can always go back and check with this method, but you guys still got to understand how to simplify. So that would be 1/20th. 5% is the same as 1/20th. Okay? All right, and the last one we're going to do on this stuff is I would like everybody to do number 12. Make sure you read the instructions. Make sure you read what it wants you to do. The last question on the summative is going to have a question just like this, where it's going to have 2 little blanks, and you're going to have to fill them both out. Okay, so we have to turn those fractions into percentages. Okay, so let's start there. The answer was 240%. Let's talk about how we were able to get that. So we know that all fractions are division problems, so we basically can do 12 divided by 5. But what you guys got to understand, what's this going to turn it into when we do the division of a fraction? Yes? A regular number, right? I call them regulars, but it is a decimal. Regular number, okay? And that is going to give me the regular number 2.4. Now we've got to take that thing and turn it into a percentage. How do we turn a regular number into a percentage again? Times 100, which is the same as taking that decimal and just moving it 2 places to the right, which is how we would get 240%. For the answers that I look on here, I see this person went the wrong direction again. They divided by 100. Okay, we got to make sure we're getting that. 8.2, I'm not even sure if maybe they were looking at different, I'm not sure where that came from. I don't know. 2440, maybe they just mistyped. That's the only thing I could think there. But we definitely got to start going the correct direction when we're turning it into percentages. All right. So this is a strip diagram. I obviously want you to use the strip diagram because I have a rectangular box right there. You got it. Okay. So first of all, when I start on my strip diagrams, I always start right here. I always start by saying I know the whole entire strip equals 100%. Okay. Now we've got to remember that there's only a couple ways that we can actually cut our strip diagram up. I'll come back to this in a minute. Okay? There's only a few ways that I can cut my strip diagram up. And really, this one we would never use. We would use this one with 4 groups of 25. Right? We would use 5 groups of 20%, and I should have percent signs on there, but I'm being lazy. But you guys should be putting percent signs on there. Okay? Or I could do 10 sections of 10%. Okay, these are the only ways that we can cut this strip diagram up. Right there. That's the only ways. So if the percent that's given in the question is 60%, am I going to be able to see 60% from that one there?
Oh.
What about from that one there? What about from that one there? So I could use either this one or this one if I'm doing 60%. Okay? So that's what I'm trying to get you guys to see. Now, what if the percent that was given in the question was 30%? Would you be able to see 30% there? No, because that'd be like right there, right? And we don't want to split it. We want it to be equal sized sections. Could you see where 30% is there? No. And then finally, could you see 30% here? Yeah, that would mean 3 of these. 10%, 10%, 10% is 30%, right? What if it was 75%? Would you be able to see 75% here? Yeah, that'd be 3 of them, right? So that's just how you break it down. That's how you figure out which strip diagram you're going to do. So you always want to, step number 1, identify the percentage that's given, which I see 60%. So how should I cut my strip diagram up? into 5 sections of 20%. Make them as even as you can. It doesn't have to be perfect. Now notice, I'm going to go through and I'm going to write 20%. I'm not going to be lazy this time. I'm going to put all the percents in there. I'm going to put the percent sign so I don't get confused. Now, I always try to show you this in 2 different colors because I want you guys to always remember, and it's amazing to me, even though I've said it over and over again, I say there needs to be 2 numbers in each piece. 2 numbers. There needs to be percent and a real number. Some sort of number. I don't know what it is. Depends on the question. Okay? I'm going to try to show them in 2 different colors. I know that I'm going to have a certain number of Skittles in each one of these pieces, right? Now, I don't know what that is yet. That's what we've got to figure out. That's the work part of this. That's what makes this a little bit challenging, correct? All right. So now let's read the question. All I did was look through it and figure out the percentage and figure out how to break this thing up. Now, the other thing I like to do is I like to shade this. I like to go through here and say, you know, I'm going to just shade 60%. Okay, just to get me thinking. I just like to shade it there. Or maybe some of you like to say, well, do these little brackets. I do those sometimes too. I don't care, but I just want you to think about what 60% is. So now let's read it. If there are 400 pieces in a bag of Skittles, how many Skittles did you eat if you ate 60%? So what is 60% representing here? I like to do labels first because that helps us understand it. Morgan? This is how many that I've eaten. Okay? I can't answer any questions right now. You're going to have to figure it out. Okay? Whereas this, what is this then? What is this 40%? What is the 40? If this is the amount that I've eaten, what is this 40%? Jaden? This is how much I have left over. Okay? So all I'm doing is putting together clues. It's kind of like goes back to remember the ratio stuff when we did edge pieces? And I said it was like there's your clues, your edge pieces, your CSI wall, I called it, I think, at one point. That's almost what you're doing. I'm just kind of looking at it, thinking about what this means. And if I had a bag of Skittles, or think about a candy bar. If I ate 60% of a candy bar, wouldn't I have eaten that much of it? If you think about it in a rectangle, and I know it's Skittles, but get my point on that? Okay? Okay. So here's what we've got to figure out. This is the real trick to this. This is what makes it hard. We have to determine whether 400 is talking about a part of the strip diagram or if it's representing the whole entire thing. That's what we've got to figure out. That's what makes this hard. And this is where you got to be real careful readers. Does it say that I ate 400? Does it say that I have 400 left over? Does it say there are 400 total Skittles in a bag? Yes. So I know right away that this whole entire strip must equal 400 Skittles. Well, if the whole strip represents 400, and I got to figure out how many Skittles are going to go into each, think about putting 400 Skittles into 5 groups. How would you do that? You would do 400 divided by 5. Some people get confused and say, well, Mr. Garrison, why isn't it 400 divided by 3? Well, it would be 400 divided by 3 if the instructions would have said, if I would have eaten 400 Skittles. Then you would be doing 400 divided by 3. But we didn't eat 400. Okay, we only ate 40% of whole, right? Of means whole, correct? 300 or 400. Okay, so we've got to figure out how many Skittles are going to go into each. So we are going to go in here. We're going to do 400 divided by 5. That's going to give me 80 Skittles in each one, right? 80, 80, 80. Now we just got to be careful readers. Are we trying to figure out how many Skittles we ate? Or are we trying to figure out how many Skittles we have left over? What's the question asking for? Deja? How many that have we eaten? Well, it's pretty easy then. 80, 80, and 80. You can put them all together. I have 3 groups of 80. That means 240 that I must have eaten in that one setting. And I know that I have 160 of those Skittles left over for next time. Everybody understand that? Now, what should you do when you get done with this part right here? What should you do? And you guys have to do it. Yes. Proportion. I would like you to all check with a proportion because you guys are really good with the proportions. Okay? The percent goes here, obviously. Now, again, we're going to use labels. What happened to those 60% of those? What happened to 60% of those Skittles, Connor? They were eaten or ate. So then this is the actual amount that's ate. This must be the total. This must be the total. Is 400 the part of the whole? Whole. So that goes there. 400 times 60 is 24,000. Divided by 100 would be 240. Doesn't matter how we did it. Did we get the same answer? Everybody seeing this? Okay. Now let's do one that's slightly different. Go ahead and do this one. Go ahead. Let's see if, or actually I'm just going to do it for you. Let me do it for you. This one for you, then we'll do another one. Okay. So here we go. This one's a little bit different. What does the whole strip represent automatically?
100%.
100%. Okay. Now, do you also agree that it equals some sort of total? Now, I'm not going to put any number on. I'm just going to write total something. Okay. Now, Olivia has saved $460 to buy a new laptop. This is 80% of the total amount she needs. So because that says 80%, how should I cut my strip diagram up? First of all, yeah. I'm going to cut it up into 5 pieces of 20%, just like we did last time, right? So here we go. There's 20%, 20%, 20%, that's 60, 20%, and 20%. Remember, it's all about dividing up 100%. Some people want to do 4 groups of 20 and make, well, it says 80%. No. We show 80% by showing 80% would be 4 out of 5 pieces, right? Okay, because remember, 80% is less than 1. It's less than 100%. Okay? Now, one thing that I said I like to do, and I'll do it again here, is you can always highlight this. If you have a highlighter on the test tomorrow, you can use this highlighter. I mean, I don't care. You can use a highlighter and kind of highlight that. Or, like I said, you can do a bracket. I don't really care. I just like to put labels on. Now, what is the 80%? Let me read it again here. Olivia has saved $460 to buy a new laptop. This is 80% of the amount that she needs. What is the total amount of the laptop? So this part that I've highlighted, what is that representing label-wise? Not number, labels.
The amount she needs.
No. It says she has saved $460. This, $460, that's what this means, right? When it says this, it's talking about that. This is only 80% of the amount she needs. So what is that 80%, Connor?
How much saved.
This is how much that she has saved. Everybody understand that and agree with that? Okay. So then what's this over here then? That's the amount she needs. So does she almost have enough money? Is she getting close? Yeah, she's got 80% of it. She's getting close to her goal here of how much she needs. So look at the questions asking. What is the question asking for? Yep.
The total.
Okay, right there. It says it in the question. So there's 2 ways to go about this. You can either identify that this is just, we have to figure out whether this is a part or a whole, right? Right, everybody? That's really what we've got to figure out. Correct? And you can do it 2 ways. You can do it by understanding that it says saved and that she doesn't have enough money, so if she's only saved that much, that can't be the whole strip. Or you can look at the question. And if the question's asking for the total, then that can't be if it said what is the total and you guys put 460, that wouldn't make any sense, would it? It says it right there. That can't be the total. Why would it give you the answer in the question? Okay? So, let's go here. Do we know this right here? Do we know this?
No.
Is that what we're trying to figure out?
Yeah.
So let me ask you. Is 460 representing the amount that she saved, needs to, or is that the total amount? What is $460 representing? Is 460 the amount she needs, the amount she has saved, or the total amount that she's going to need to buy the whole thing? Yeah. Has saved. So I'm going to go ahead and write $460 right here. Everybody agree? Everybody agree with that? Now comes the million-dollar question that all of you, not all of you, some of you are struggling with. The reason why you're missing these is because you get confused now on what to do. We all know if I asked the question, okay, what are we trying to do? You would all say, well, we have to figure out how much money is in each one of these, right? That's what we've got to figure out as a class. That's our goal right now, is to figure out money. So how are we going to do that? How are we going to do that? This is the confusing part of these. Alyssa? 460 divided by 4. Does anybody disagree? Does anybody think it's 460 divided by 5? Okay. Why is it not 460 divided by 5? Because that's what you guys want to do. Why is that incorrect? Nate? Yes. Yes. What I have highlighted in green, that's 460. Not all 5 of them. 460 is only representing the 4 pieces in green. So we would not do 460 divided by 5 because 460 is not a whole. It is only a part. So when we do that, we get 115 in each one. Okay, now remember, our question is asking for us to find the total. Give me one way that I can find the total. Jaden? Times what? 5. Good. Could do it that way. What's another way you could do it? Yep. All you got to do is add 460 plus the amount she needs, which is 115. That would give it to you also. Either way, we're going to get $575, right? So there's our answer, $575. Okay? Now what's the last step? What should we do? Just to make sure we didn't make a mistake. Morgan? We're going to check with a proportion here. So we're going to do part over whole equals percent over 100. I know the percent is 80. Now, what is that 80% again? It's the amount that she saved. So this is going to be the actual amount she saved. I hope you're paying attention. I'm going to find out in a minute. Save to total, save to total. So is 460 the amount she saved, or is that the total amount she needs? Saved. Cross multiply. When you do 460 times 100, you're going to get 46,000. 46,000 divided by 80 will give you $575. Everybody see how I'm doing that? Does that make better sense now? Okay, let's try another here. Hold on one second. I would like you guys to all try this one up here. This one, please. So everybody got it right. That makes me happy. 1,050. Very, very good. That's awesome. Okay? And these are the harder ones, I think. So when we look at this, first thing I always identify is the percentage. Okay? So that's where I'm going to start. I identify it's 80%. I know I kind of erased it there, but I know that tells me that I'm going to cut it in 20% sections, right? 20%, 20%, 20%, 20%, and 20%. I know the whole thing equals 100%, right? Now, Mrs. Godfrey has saved $840 to buy a new laptop. This is 80% of her total amount. What is the total amount she needs? So this, like the one we just did, is the exact same type of question, right? Because I'm going to highlight 80%. We are trying to figure out the total. We do not know the total cost. That's what we're trying to figure out, right? So once again, I'll use this little bracket here. What is that 80% representing? The amount that she has saved. This must be the amount that she needs. And this obviously is the total cost of that laptop. So I know that $840 is the part. Again, it only represents those 4 sections, so I'm going to divide it by 4 to put $210 in each one of these. So if I'm going to figure out the total, I'm going to add 210 5 times, or I'm going to do 210 times 5, or I'm going to say, well, if I know that the amount she saved is 840, and I know she needs 210, I can just add those two. Either way, you get $1,050. Now, we should always check with a proportion. I hope you guys are doing this, because we're not going to do any of the proportions. This very same question, guys, could be a proportion, could be on the test, only not using a model. You guys all understand that, right? They're the same questions. It's still part to whole equals percent over 100. And we look at this and we say, okay, Mrs. Godfrey has saved $840 to buy a new laptop. This is 80%. We know this is the amount that she saved. This is the actual amount she saved to total. So let me ask you, is 840, the number that was given, the amount she saved, or is that the total amount of the laptop? There you go. Cross, multiply, divide, you will get 1,050. It'll check your work for you. Okay? All right. Here we go. A pair of Black Ice Kyrie 3s are originally $120. Since I am a Nike employee, I receive 30% off anything I want to buy that's Nike. That's normal. If anybody's parents or maybe your brothers work somewhere, they get usually their family gets like a discount for just because their kid works there or whoever works there. Okay? So obviously, you guys should all know that a proportion's coming. Anytime we're doing tax tip discount, I've shown you proportions. This whole chapter's been proportions, right? So we have to do a proportion, and that percent proportion isn't going to change. It's going to be part out of whole equals percent out of 100. Now, I see 30% up there. Now, this is where, as I was walking around, I was looking just to see how many people actually showed the labels. And even though I keep saying it, most of you are still not doing it. And I think if you do it, it kind of takes the thinking out of it, so to speak. What is happening to 30% of the cost? What's happening to it? What is that 30%? Yes?
He's receiving.
No. Yep. It's the discount. Now, you could write it different ways. You could say discount. You could say the amount off. You could say the savings. I don't care how you say it, but it's any of those words. Now, since it says find the discount, I'm just going to call it discount because you guys all know that discount is the amount that you're saving on an item. If something is $50 discounted, that means we're going to subtract $50 from the cost, correct? Okay? So, we know that's my discount. So what I'm going to do now is we always put it here too. Because if the top is discount there, the percent is the discount, then this number right here also has to be the discount. Right? Now remember, whenever you're finding discount, tax, or tip, the first step is you must find the percentage of the total amount or the total cost. Now we know of means the whole. It does mean multiply, but doesn't of represent the whole? Right? So we know that 120 is going to have to go here. So all you had to do is figure out what this is right here, and that's your answer. So you had to cross, multiply, and divide. 30 times 120 is 3,600. 3,600 divided by 100 is going to give me $36. That right there is the discount. Nothing more, nothing less, $36. That's what it is. Okay? Now, when you guys get to the... Does that make sense? What doesn't make sense? I mean, that's when you multiply. You did something wrong, man. Okay, so $36 is the discount. Okay? That's just the discount. So down here now, on the summative, you guys are going to have the part 2. What is the sale price? Okay, well, if I'm talking about sale price, that means the price after the discount. Like, how much is it actually going to sell for? It's not like I'm going to go in and pay $120, am I?
No.
I'm not, because I'm a Nike employee. So it's not going to be $120 coming out of my cart or out of my account. It's going to be less than that because it's discounted. So what would we do in order to figure out that sale price? Yes? So I'm going to take 120, my original cost. I'm going to... 120 minus 36, and that is going to give me my sale price. It's the original price minus my discount, and it's going to be what? $94. No, it's 84, isn't it?
No.
It is 94, you're right. Okay, $94. Are we seeing how to do that? Okay?
No, it's 84.
I thought it was 84. Okay? $84.
Yeah, it is.
Okay. All right. Now this one, let's just kind of do together here real quick. I'm going to get you started. You know you're going to have one like this on the summative also. How many proportions are you going to have to do?
2.
2. You're going to have to do one that's going to find your tax amount, and then one finding your tip amount. So we put this on there. We know it's going to be part over whole equals percent over 100. I write it every single time, don't I, guys?
Yep.
Part over whole equals percent over 100. Now, we know that our tax amount 7.5 is going to go there. Our tip amount 19. Now, if you want to do labels, I didn't leave myself a lot of space, but labels don't hurt. There's my tax, so that must be the actual tax. This is my tip, so this must be the actual amount of money that will be my tip. Everybody see how I'm doing that?
Yeah.
Now remember, when you're figuring out tax and tip, you have to be able to realize that the first step is you got to figure out 7.5% of the food bill or the dinner bill. 19% of the dinner bill. So right now, is the dinner bill always going to be the part or the whole?
Oh.
It's always going to be the whole. Okay, so I'm going to put that on there, $48.68. $48.68. Okay, and obviously we're trying to figure out the tax and tip. That's why those are blank, right? Okay, so we cross multiply and we divide. Let's figure out what that gives us. Who wants to do it for me? I'll do it on here, actually, because I want to see the rounding thing. Okay. Sorry. Okay, so here we go. We know it's going to be 48.68 times 7.5 divided by 100, and that's going to give me 3651. Now, I'll write it up here. 3651. How many places does money go to? 2 places. So I draw my line right there. This is either going to be $3.65 or $3.66, right? It always rounds right there. So now we've got to understand our rounding rules. The number to the right of that place value, if it's 4 or less, we let it rest. When it's 5 or more, we raise the score, right? In this case, are we going to let it rest? So it's going to be $3.65. Now the other one, let's do that one real quick. See if the rounding's any different. We got $48.68 times 19 divided by 100. Oh, 92492. So we got 924. What was it?
92.
92. How many places does money go to? Goes to 2 places. So this is either going to be what or what? What's it going to be? It's going to be this one, because that 9 right there tells that 4 to go up because it's 5 or more. The 9 is. Everybody got that? So that's going to be $9.25. So here's my question to you. How much money is going to the government? $3.65 going to the government for the roads and whatnot there. Okay, how much is going to my server, the person that brought me my drinks, brought me my food, brought me my ketchup, whatever? $9.25. That's how much they are getting. Okay? As me, the total cost, what I'm trying to figure out, when it says total cost, it's trying to figure out how much am I, the person at the restaurant that ate the food, how much am I going to pay? The biggest mistake I saw in the formative is people are taking this and adding it to this. And they're saying, yep, that's going to be $12.90. Does that make any sense? I wish I could go to Applebee's and I wish I could buy $48.68 worth of food and drinks, pay my tax, pay my tip, and then only have to pay $12.90. Does that even make any sense? But some of you are doing it. Remember, we've got to add the food bill. We have to come back to it and we have to say, okay, we have to add our food plus the tax plus the tip. Now, on the formative, I saw many of you were taking this and you're adding it like this, 365 plus 925, and then you're doing this and carrying. That's all great. Hold on, guys, please. That's all great if you want to do that. But I am asking you, and I don't know why I'm having to ask you this. It should be, you should want to do this. You are all allowed to use a calculator. If you want to do it the old-fashioned way, the elementary way, that's fine, do it. But please just take an extra 10 seconds and type it into your calculator, okay? Just to check. All right. So, and I see an awful lot of calculators up here, which kind of tells me that maybe not everybody has one, but maybe you have your own if you don't have one. And I'm pretty sure I said get a calculator, so get one. Okay? Whenever we are turning a regular number into a percentage, can you go ahead and type 95 in there for me? Yes, sir, please. Thank you. Okay, so we have a couple different answers. Now that person obviously right there, they wrote the wrong number accidentally. That's a silly mistake. Now, right here, I have, what? Well, screw up then. Okay, that number is 0.95. 95 hundredths. Correct? So for the two people that put 0.95, that doesn't make much sense because it's not going to stay the same. That's like you saying that 100 is the same as 100%. Is that true? Is that true? 100 and 100% the same thing? No. If I have 100 pizzas, then I have a lot more than 100% of a pizza, right? Remember, the regular number 1 always equals the percentage 100. One whole pizza is the same as 100% of pizza. So when you have 0.95, right, when we're turning a regular into a percentage, what do we do to the regular number, Sanaya? We multiply by 100. So you could just calculate that out, or you could know, okay, Mr. Garrison has taught me over and over that whenever I'm multiplying by any 1 followed by 0, so that would be 10, 100, 1,000, a million, a billion, a trillion, you have to just move the decimal to the right, however many zeros there are. So in this case, we would go 1, 2. That would be 95%. All right? Okay, let's try another one. Let's try this one. Make sure you read carefully on the instructions. Okay, so on this one, the answer, we were trying to turn 2/5 into a regular number. So remember, there's a bunch of ways you can type 0.4. You can do 0.4, 0.40, 0.4, 0.40. You can do 0.400, 0.4. You know, you could do as many zeros after the 4 as you'd like. So really, we had a big bar here that put 40. So let's talk about what they did. Okay? Now, you guys all know and are very well aware that all fractions are division problems. So you were all able to get 0.4, which was what kind of number? That is a regular number. I mean, that's what you do when you divide it. You are figuring out the regular number. Okay? For the people that got 40, this 6 people that put 40, can somebody explain to me what they did? They got 40. What did they do, Owen?
They just turned the fraction into like something over 100.
Yeah, they did it. You can think about it 2 ways. You could think, okay, all fractions are division problems, and that regular number is 0.4 or 4/10, right? Then they multiplied by 100 to turn it into 40%. Does everybody in the room agree that 0.4 is the exact same thing as 40%? Do we agree with that?
Yeah.
Absolutely they are. But it didn't ask for a percent. You guys see that? Does it say the word percent anywhere there?
Not at all.
No, it does not. So you just got to be careful readers. Okay? Remember, the other way that they could have done it is they could have went like this, part over whole equals percent over 100, and they would have gotten 40. But remember, that's the percentage, not the regular number. Okay? I would like everybody to go ahead and try number 9 here. Number 9. The correct answer here was 4/5. Okay, now a couple people were in the middle of it, still that is wrong. And this person, they actually are thinking right, but what did they forget to do? 8100. Simplify, right? And SF stands for simplest form. Okay, now we know that all percentages are a fraction out of what? 100. And then from there, we can just simplify. Now, you could have done it a couple different ways. I know a lot of you probably went ahead and did 80 ABC 100 in your calculator, and I guess that's fine. But let's not forget how to simplify. we have to figure out a number that divides both 80 and 100 evenly. Yes?
Well, you can take away the zeros in it.
You could just take away the zeros. Now, when you just take away zeros, that's fine, but understand what you're actually doing is you're dividing by 10. Because again, when you multiply by 10, you move it one place to the right. When you divide by 10, you're moving your decimal to the left one place. So then it becomes 8 over 10. Now, what should you notice about those two numbers right away, Tyler?
They're both even.
They're both even numbers, so there we go. That's going to get us to the fraction 4/5. So therefore, 4/5 is the exact same thing as 80%. Okay, they're equal to one another. 4/5 of a pizza, I could say, hey, I have 4 out of 5 slices left of my pizza. Or I could say, hey, I have 80% of my pizza left. Same exact thing. Everybody understand that? Okay. All right, let's get away from these for a little bit. Let's go in and do these. Stop and listen. Here we go. Here's another modeling question, guys. If there were 40 questions on a test, and Mike received a 75% on the test, I should say test, how many questions did he get correct? So when I'm looking at this saying, okay, I know the whole thing equals 100%, I automatically see 75%. So how am I going to cut this strip diagram up, first and foremost? Let's start there. Big Will? I'm going to cut it into 4 groups of 25%. So I'm going to have 25% in there, 25% there, 25% there, and 25% there. Now I'm going to get out my highlighter. If you have one on the test, I'd use it. And I'm just going to go ahead and shade 75%. So do you agree that that's what Mike got correct, though?
Yeah.
I mean, think about it. If he got a 75% on the test, that means he got 75% of it correct. He got 25% of it incorrect. Okay? Everybody understand that? Okay. Once again, if you want to use brackets, nope. You won't hear one complaint out of me. I don't care. So, we have to determine whether 40 is a part or a whole. That's what we've really got to figure out. Okay? And my question to you was, if I were doing this question, you should be able to think about this one logically, as if you were that student. And think about it. If there were 40 questions on a test, and if you got 100% on it, okay, how many questions did you get correct? If there were 40 questions on a test, and you got 100%, how many questions did you actually get correct?
30.
Yeah. 40 of them. In order to get 100%, you have to get all of them correct, right? So a 40 out of 40. Now, Mike obviously didn't get 100%. So that should have been an automatic, that should have told you right away that this has to be the whole, right? So let's think about this. What did he do to this? What is happening with this 75% of them? What did he do? Yeah. Well, he got them correct, right? That's what he got correct. This is what he got incorrect or wrong, right? Right? Okay. So what do we know? Do we know how many questions he got correct, incorrect, or the total questions on the test? What do we know? Yes. We know the total. So we know this is 40. So remember, there should be 2 numbers in every one. So we need to figure out how many questions would we put in each box here. So how are we going to figure that out, Dylan?
By dividing 40 by 25.
No. There are not 20. No. 40 is the whole, the total. It represents the entire strip. If Mike would have gotten 100%, he would have got 40 questions correct. So we are going to take 40 and divide it by 4. Because we need to know this. And if we can divide it by 4 and get 10 in each, then can we look at it and say, well, how many did he get correct then, guys?
30.
He got 10, 20, 30 correct. Everybody see that?
Yeah.
Okay. Now let's check with a proportion here real quick. Part over whole equals percent over 100. I put 75 there. Is 40, or what is the label I would put with 75%? Yeah.
How much you got correct?
Correct. Correct. Total. So is 40 the amount you got correct, or is that the total amount? Yep. The total. 40 times 75 is going to be 30,000, I think.
Yep.
And then 30,000 divided by 100 No. 3,000.
Yes.
3,000 divided by 100 would be 30, correct. Right? Everybody got that?
Yeah.
All right. Hold up. Okay, guys. You know there's going to be a question just like this one on the summative because it was on the formative. Now, on the formative, we did football cleats. First of all, everybody should have done a proportion, number one. Right? Should have done a proportion because that's pretty much 90% of this test is doing this percent proportion. Okay? Now, obviously, it says what percent, so right away, you should have all made the connection that this is what we're trying to figure out. Now, notice how it said what percent of the shipment. Of the shipment. When you see the word of, what usually follows? The part of the whole.
The whole.
The whole. So we're talking about the shipment, and then it says R sandals. What is R a form of? What word?
Part.
But what is R the same as, essentially? Yep.
Is.
Is an R? Like you say, give me an example here.
There are dogs.
Yeah, but that's because it's plural. If this was is sandal, you would say is, right? R and is are basically the same word. Everybody understand that? So we got to understand here the part, we're trying to figure out what part the sandals are. So this would be the sandals, right? This would be the sandals. And there are 42 sandals in that shipment. This is the total. So we must add up all of those to get 110. And when you cross multiply and divide, you end up getting this, 38. What was it again? 181818?
38.18.
181. Okay, so if you rounded this, there's a couple ways you could have done it. If you rounded it to here, it would have been 38%. If you rounded it to here, it would be 38.1%. If you would have rounded it to here, it would be 38.18%. If you'd have rounded it one more, it would be 38.182. The 1 would go up to 2 because of the 8. So any of those would work. Okay? Everybody understand that? So when you get that question on the test, your part is just whatever it's asking for. The sandals or the dress shoes or whatever. The total is going to be the whole shipment.
So
Okay,
technically, yes, 38.8.
It should have
but we
been
rounded 100.
38.2%, sorry. Or 38, or 38.18%. That's what your options are. I messed this one up, sorry. Just as a reminder, when you're doing these, part over whole equals percent over 100, that hasn't changed. But when you're doing just these ones without the word problems, what words help us to identify part and whole? What words, Faith? Yeah, the part really, is and of are really going to help you to see those. So first of all, I see the words what percent. I see that, Myra. And then I don't see a percent sign on anything. So that told me right away that this must be what I'm looking for, right? So which one is the part? 18 is what percent of 30? What's the part? Yep.
Because 18 is before is, so 18 is.
Yep. And then of 30 gives it away for 30. You're going to cross multiply and you're going to divide. You're going to get 60, right? 60%. Okay. Let's do one more of those. I want to do a different one. I want to do. Let's do this one. This is the one always confuses people. This one right here. Go ahead. Okay, so this one here, guys. Again, percent proportion has to happen. If you try to do it any other way, you're crazy. Because this makes it pretty easy. What's the first thing that's the easiest thing to identify on there? Kunko? The percentage right there, so that takes care of that. Then it says, of what number is 124? So is 124 the part or the whole? Aiden?
Part.
There you go. Cross, multiply, divide. Is it 310?
Yeah.
310. All right, let's go on. Here you go. Go ahead and do this one. Okay, here we go. So you know you're going to have one just like this on the summative. Okay. Should we do a proportion?
Yes.
Absolutely. Part over whole equals percent over 100. I look up there. The cost of a coat at Target is $145.25. At Target, they're having a Martin Luther King Day sale, and which gives you 40% off discount. So I know 40% is going to go there. Now I keep telling you guys, labels, labels, labels. Some of you are still not doing it. But what would I label this? What is this 40%? It's my what, Kylie? It's the discount, or you could say the amount off, or the savings. I don't care what you say, just as long as you understand. But we'll call it a discount. Now, remember, when you're doing tax, when you're doing tip, when you're doing discounts, the whole idea is you have to figure out what 40% of that is. So whenever you're doing this, is this always going to be the part or the whole? The whole. Okay, so we're going to put that there. That's going to be 145.25. Now we're going to cross multiply and we're going to divide. What does that give me? Somebody tell me what it gives. Owen? 58 point what? Okay, that's not money.
Yeah, but then you round it and add a 0.
Okay, but I want to know what the calculator said to you all the way. Kofi. Was it 110? Oh, I just said 58.1?
Yeah.
Oh, okay. So, I got you, my bad. Okay, so yeah, that right there, I thought you had it round. 58.1 I would not accept, but $58.10, just for kicks and giggles, let's see if anybody put 58.1. Man, guys. I mean, it's so frustrating. Guys, this money goes to two places. You've got to add the decimal on there. You've never in your life seen anything cost $58.1. You've never seen that ever. So you guys need to quit doing it. So $58.10. Now here's what people get confused on, is they say, okay, do I have to subtract? Do I have to actually do 58.10? Do I need to subtract here? No! What's the question asking for? The discount, because that's the percent discount. This is the actual discount. You do not subtract here. Let's see if anybody did. Well, a couple people. Yeah, but even added, I don't think it. Okay, I don't know. But just know, on the summative tomorrow, you're going to have this question. It's going to say find the discount. Guys, that is the discount. Then, below that question, it's going to say find the sale price. Now, the sale price is how much it costs, how much you had to pay after your discount. What are you going to have to do here? What are you going to have to do now? Come on, guys. Okay, what are we going to do, though? Yeah. We are going to take the original price of that jacket, and we are going to subtract the discounted amount. Because we need to figure out how much we're going to pay for that coat. You need to subtract that. I don't know what it gives you, 88 something. $87.15. Okay? Everybody understand that? This is the sale price. This is the discount. Okay? Let's do... What's going on here? Hey, just to help everybody get started here, how many proportions are we going to need? Oh, okay, just check it. 2 proportions, right?
Yes.
Okay, keep going. Yeah, right. All right, hey. Here we go. We know we're going to have one just like this on the summative once again. I mean, I don't put stuff on these reviews that are not going to be there. That would be a waste of your time. What are you doing? You got about 5 minutes left.
This happened yesterday for some of you guys. Why are we packing up early?
Okay.
Rude.
We know that we're going to have one that we're going to calculate our tax for, one that we're going to calculate our tip with. We're going to use the 2 proportions. Now, both of them are going to be our percent proportion, so we all should have done this. Have you guys gotten in the habit of writing part and whole on every single one?
Yeah.
Good if you have, because every time I do it, I take the extra time, right? And I do it 4 periods a day. Think about that. I do it every single time, because it helps to remember. Helps to remind you, I should say. So we know this is my tax, so I'm going to go ahead and write 8.5 there. Now I'm going to put 22 there. Okay? Now, if we were putting a label on this, what would be my label?
Yep.
Tax. This would be the actual tax. This would be the tip percentage. This would be the actual amount of money tip. Now, we've got to remember that when we're finding tax, what we're really doing is we're figuring out 8.5% of that and 22% of that. So why am I telling you that? Because we use the word of to mean what? Part or whole? Whole. So we know that 6283 is going to go in the whole spot on both of these. 6283, 6283. Everybody got that?
Yeah.
Mr. Zinker, will you help me type in these? Cross, multiply, divide there?
Yeah.
You can do it on, well, I'm on it here.
Oh, sorry.
Thank you. I guess I can. Okay, cross multiply, now divide it by 100. Okay, so I'm going to write that 5340. 5.340. Now, how many places does money go to?
2.
So, let me ask you, what is this going to be? This is either going to be $5 and
34 cents.
or $5 and 35 cents. So what does that 0 tell that 4 to do? Stay or go? Stay. So this would not be right. It would be $5.34.
Yes.
Now let's calculate the other one there. Okay, we're going to cross multiply. And then we're going to multiply by 22. And then we're going to divide it by 100. Okay, 13,826. So 13,822. That's all the farther I need to go. This is either going to be what or what? Yep.
So it's either going to be 13.83 or 13.8.
You got it. No, I see people writing. I'm not sure why. What's this going to be? Is this going to be $13.82? Or $13.83? There's supposed to be a 3 right there. $13.83, Tyler?
$13.82.
It's going to be $13.82. Now, what's the final step that I have to do to find the total cost for me as the person at the restaurant? Owen?
Add tax, tip, and a total.
So food plus tax plus tip, right? I still had people yesterday, guys, simply just adding the tax and the tip together, and they were getting an answer that was around $16 or whatever. Does that even make any sense? I wish I'd be fine with going and getting a meal for $62 and then paying only $16, right? Wouldn't you? Okay, so where's this money going?
To the total.
Who gets that money? That $5.34 though. The government gets that. Who's getting this money right here? The waiter or the waitress. Your server, the person that brought you food and drinks and extra stuff that you needed. Okay? And finally, who gets this bill right here?
Restaurant.
The restaurant, so they can buy more food and pay their employees, right? So we must add all of those together. Now I see people on their formatives yesterday doing this. Now, if you want to do it this way, and by the way, a lot of people did this. A lot. And if you want to, fine. I couldn't care less. If that's what you want to do, do it. But when you get done, will everybody please promise me that now, just go ahead and check it in your calculator. Because there's no sense in doing all this work, everything here, and then messing up the thing that you learned in third and fourth grade. Right?
Yeah.
So you can use a calculator. I don't mind you doing it this way. I kind of like the practice, but at least check at the end. Does that sound good?
Yeah.
All right. Okay, so we'll end this right here. Correct answer was 2,000. Thank you. All right, so 10 of you got it right, 4 of you got it incorrect. Okay, now how could the number 20, if you're converting it, how could it be 20%? That doesn't make any sense. 20, the whole number, the regular number 20 would be having this many pizzas. Right? Wait. It's like 12. There we go. That's 20 pizzas, right? Do I have more than 100% of a pizza?
Yeah.
Do you guys agree with that?
Yeah.
So you can't have a regular number and a percent be the same number. Okay? Like I keep trying to tell you guys, the number 1 is equal to what percent? 100%. That's why we multiply by 100 when we're turning a regular into a percentage, right?
Yes.
So 20%, you must take the number 20, multiply it by 100 to get your 2,000. Everybody understand that? Got to make sure we're getting that, guys. I can't believe that many people missed it, to be honest. Okay, let's go on to this one. Go. So for this one here, you can see we had both bars getting correct. Remember, it doesn't matter if you put the 0 in front or not. Okay, but we had 9 of the 14 get it right, so 5 people are missing it here. We'll talk about what those people did, the people that missed it. Okay, when I want you to turn 3/8 into a regular number, that doesn't mean that I want you to do this. What are you turning it to if you do that? Yep,
A percent.
a percentage. Now, you could do it this way and then convert it back to a regular, but you got to understand that we're not turning it into a percentage, correct?
Right.
So the easiest way I would say here is to do 3 divided by 8, and all you have to do is get 0.0375. For the people then that multiplied it by 100, you're converting it into a percentage. You're doing a step that the directions say nothing about, right? We've got to get these conversions. We've got to get this down, okay? And finally, let's do this one right here. Go ahead. The good news for that one, 22% becoming a fraction, everybody got it right, kind of, but we got to remember, what do we always have to do to fractions? Always, no matter what it says or what, yeah.
Put it in simplest form.
Put it in simplest form, that's every time. That's not a sometimes kind of thing, that's all the time. So, we know that all percentages are a fraction out of what? 100, and then we got to simplify it, which we see that they're both even. So we're going to divide 2, we're going to get 11/50ths. Okay? All right. Let's go on here. Let's do a strip diagram question. Okay, I would like everybody to do the top one, please. The top one. Everybody listen. So let's see how we did. Everybody got it right here except for one. The answer is 210. Now let's talk about how we got 210. Now the one person better be paying attention. Hopefully we can figure out what their mistake was here. So when you're doing this, when you're doing these, what does the whole strip always represent? Yes? Lears.
100%.
And then what else does it represent? Some sort of what? Lears.
Total.
Some sort of total, whatever we're talking about. In this case, we're talking about total cost, right? All right, what's the next thing I should always identify? Yes? Which I learned what that's going to be based on whatever the percent that's given in the problem, right? Since 60% was given in the problem, how should I cut my strip diagram up? Christian?
20%.
20%. Could I also do 10% sections?
Yeah, that would take forever.
It would, but it would take a lot longer, exactly. So we got 20%, 20%, 20%, 20%, 20%. Okay? Now, inside every little piece of my strip diagram, this one and this one, how many pieces do I need in there? How many numbers, I mean? How many numbers should be in each one of my strip diagram? We have one now. How many needs to be in there, Christian?
2.
You need to have 2. You need to have a percent, and then you need to have a real number, a regular number, right? Okay. So now we'll go up and read it because we haven't even read it yet. And I like to also do this too. If you have a highlighter, I think that this is nice. Highlighting the whatever the percent that's given is, highlighting it like that. Or maybe you're just somebody that likes to do the brackets. I don't really care. There we go. So Mr. Zenker saved $126 to buy a new TV. This was 60% of the cost. What does the TV cost? Does Mr. Zenker have enough money right now to go buy a new TV? No, he does not. So he needs to save some more. So what's highlighted in yellow is 60%. What is that representing though? Like what are we talking about? Why did I highlight that right now, Hope?
The money that he has saved.
That's how much he has saved. So then what is this going to represent then? Aaron?
Total cost.
No, that's just these two.
How much you need.
How much he needs, and this over here is the total. So ask yourself real quick, does 126 equal the amount that he needs, or the amount that he saved, or is that the total cost of the TV? Selby? That is the amount saved. So we have $126 right here. Now, what do we have to do? Now, what's that next step? We always need to what? Aaron? We need to figure out an equal amount of money in each one of these boxes. And because this is just the amount that he saved, we're only going to divide it by the 3 pieces that he has saved. So when we do that, we're going to get $42 in each one of these, right? 42, 42, 42. How are we going to figure out how much his total cost of his TV is going to be then? How are we going to figure that out? Hope?
You do 42 times 5.
You do 42 times 5 to get 210. The other thing you could do is, could I add the amount that he saved plus the amount that he needs?
Yeah.
Could you do 126 plus 84?
Yeah.
That would be the same thing, right?
Yeah.
Now, because I've been preaching it over and over again, what should you do at the end of this just to check your work? For instance, let's actually, you know what, I don't want to do it that way. I actually want to do it like this. Let's say that this wasn't a modeling question. Let's say I just gave you that question and I said, tell me the answer. How much money would he need? How would we go about doing this then? Stella? We would use a proportion. So now let's just do that. So we're going to do our percent proportion. So that's going to be part over whole equals percent over 100, right? Okay? We know the percent's going to be 60. Now I like to put labels, right, as I've said 100 times.
Yeah.
What labels would I need to, what is the 60%? What's happening to that 60%? What is 60%? Lears?
How much he saved?
That's how much he saved for his TV. So if that's the percent saved, isn't this the actual amount that's saved?
Mm-hmm.
And isn't this the total?
Yep.
So is 126 the part or the whole? Is it the amount he saved or the total amount, Tiffany? It's the saved amount, so there we go. We're going to cross multiply divide. We're going to get 210. Everybody understand that?
Yeah.
Okay. Let's do the one below that now. Go ahead. I'll do it quickly. Okay, so here we go. Aiden got 24 questions correct on his quiz. If he received a 75%, how many questions total were on the quiz? So obviously right here, first of all, we know that the whole strip equals 100%, right? Then we identify this. How should I split up my strip diagram? How should I split it up there, Halkamani? 4 pieces of 25%. 25%. 25%, 25%, 25%. Okay? Now, I'm going to go ahead and shade 75% because if Aiden got 75%, then that means he got 3 out of 4 pieces, right? Makes sense. 3 out of 4, 3/4 is 75%, right?
Right.
0.75. It all comes together, right? So when I look at this, and once again, you can do brackets, that's fine. What is this 75% representing label-wise? I want to know a label. What's it representing, Christian?
What he got correct.
The amount that he got correct. So obviously this over here, the one that's not shaded would be what? The amount that he got, wrong or incorrect, right? So we'll just say wrong. So over here we know we're talking about total questions. So ask yourself real quick, is 24 questions the amount that he got correct, incorrect, or the total questions on the test? What is it? Yeah.
Correct.
He got 24 correct, right?
Mm-hmm.
Right. Right.
All right. So looking at this now, I say, okay, I need to figure out how many questions are in each one of these boxes. How am I going to figure that out? Aaron?
24 divided by 3.
I'm doing it divided by 3 this time because, well, this was actually the same as the last one, where I gave you a part. But it's the same thing that it's giving you a part of it. Okay, so if it only represents three rectangles, 3 little pieces, then I can only divide it by 3. So that's going to put 8 questions in each one, which gives us a grand total of 32. That means he got a 24 out of 32. Agreed? Now what should we do at the end? Yep.
Portion.
check with your proportion. Now I'm just going to go ahead and get rid of let's imagine that this wasn't even there, like the whole model wasn't even there on the paper. So I wouldn't want you to use it. I'd want you to use a percent proportion. The only time I want you to use the model is when when it gives you the model. Okay, so part over whole equals percent over 100. I see 75%. Now, what is 75% again? Lears?
How much you got correct?
Correct. Total is 24 the amount you got correct, or the total questions on the test? Yep.
Question is that you got correct.
There you go. 24 cross multiply divide, we would get 32. Everybody good with that?
Yes.
Okay. Alrighty, let's go on. Let's see what else we got. Alright, we've done those. Let's do this one.
Wasn't this one like on the test except
Very
for
similar.
purple?
Go. What percent of the shipment are dress shoes? Alright, so let's talk about this problem here, because you know you're going to have one just like it. It might not be shoes on the summative. Maybe on the summative. It may not be shoes. It may be purses or something like that. Anyway, regardless, it's the same process though. So we know we're going to solve this using a proportion, specifically the percent proportion, right? Now, since it says in the question, what percent, that should indicate right away that this is what we're trying to figure out. So you're going to know the part and the whole. Is everybody hearing me?
Yes.
You're going to know the part and the whole. You're trying to find the percentage. Okay? So it says, what percent of the shipment are the dress shoes? Now, real quick, what is "are" the same word as? Yes? It's the same as "is." We just don't use "is" when we're talking about something plural. Dress shoes, we wouldn't say "is dress shoes." That doesn't make any sense. We would say "are dress shoes." Now, that should help you. But think about this for a minute. We're trying to figure out what would the percentage end up being? What are we trying to figure out that, like, what is the percentage? Is what I'm trying to ask. Hello? What is the percentage going to tell us, yes? But how many of the dress shoes are, right? The percent that's dress shoes. So if that's the percent that's dress shoes, this is going to be the actual amount of dress shoes. This must be the total, this must be the total, right? See how I did that? So now I'm looking at it going, okay, how many dress shoes do we see up there? 16, right? How am I going to figure out the total shipment there? Lears?
You have to add 24, 16, 28.
Add all of these together, good, which is 110. Then from there, we're going to cross multiply, we're going to divide.
I got it.
All right, I got it.
It's 14.5.
I want to type it in because I want to look at it. 16 times 100, which is 1,600. And then we're going to divide that by 10. Wait.
110.
Ooh, yeah. 110. And that's going to be that, 14.5454. So I'm going to write that now. 14.5454. Okay? Now, this is where, and I'll go back to what you guys all put in. And you guys are a pretty good group here. We have somebody that put 14, we have a bunch of you that put 15, then we have one person that put 16. This is a little bit troubling for me that we still have so many people continually missing questions only because of rounding. That's the only reason you're missing it. And that's a little disappointing. Now maybe the person that put 16, maybe they just put 16 because it was there. I'm hoping, I don't know. So let's look at this real quick. If we were rounding to here, right there, okay? That means that this answer, if I was going to do it, it's either going to be 14% or it's going to be 15%, right? And what does that 5 tell that 4 to do? Go up. So if we were rounding right there, it would be 15%. Okay? If we were rounding, right over here, 14.5454, if we were rounding to the tenths, it would either be 14.5 or 14.6. What does the 4 tell the 5 to do? Stay where you are. Okay? If we were rounding to the hundredths, right there, we were rounding there, it's either going to be 14.54 or 14.55. What's it going to be? 14.55. That 4 looks to the 5 to the right a bit, and it says go up, raise the score, 14.55. But I was told you all to round to the whole percentage there, so that's why I wanted 15%. Everybody got it? Okay. A couple of these. Here, I'm only going to do one of these on here. So right here, all these are going to be on there. You know that. You know to use the percent proportion. Now I'm going to do one quick reminder here. What were the words that help us identify the part or the whole? Hope? Is helps us to identify the part. Of helps us to identify the whole. Okay? Okay?
Okay.
And when you see the percent symbol, doesn't matter what question, whenever you see that symbol right there, you know right away that that number, doesn't matter whether it has an is in front of it, of in front of it, that doesn't matter at all. It goes right here. So we knew 12% goes there. Now we've just got to figure out whether of 35 is going to represent the part or the whole. What is it? The whole, right? We're trying to figure out the is. We're going to cross multiply, we're going to divide, and evidently we get 4.2. Was that right?
I wrote 15. Why do I get? I wrote 15.
All right, let's go on.
Today,
Here we go. Do this one real quick. Okay, guys, you're going to have one just like this on the summative once again. It might not be Under Armour shoes, but it's going to be something. Watch, because I feel like some of you are making it a little bit more complicated than it needs to be. Okay? So, Finish Line's having a sale on their Under Armour shoes. It's 25% off. The original shoes that I want is $165, but am I going to have to pay $165?
No.
No, because they're discounted. They're off a little bit. You're going to get some money, but you're not going to have to pay that much. I guess what I'm trying to say. So, are we going to have to do a percent proportion? Okay. Now we do that. I'll go ahead and put that on there. Percent over 100, part over whole. Okay. Now, we know 25 is going to go there. Now I'm going to put a label on this. What is that 25%? What is it? What is it? What is it? It's the what of this problem? It's the sell. It's the discount. It's the money that you're saving. So if that's the percent discount, isn't this going to be the actual discount? Hello?
Yes.
And this is going to be the total. Now, whenever we're finding discount, we've got to figure out the percent of the total cost, the original cost of them, right? So that means that's the whole. So we're going to put 165 there. From there, we're going to cross multiply and we're going to divide. So if I were doing this, I would do 165 times 25 and then divide that by 100. And that's going to give me 4125. No rounding necessary on that one. It actually came out to 2 places and everything. Here's where people get confused. And as I pull up the answer, go ahead and type in 41.25, please. Okay? We have a couple of these. I don't know what this person did. Now this person, I know what they did. 660. I have no idea where that came from. I'm not sure. I'm just not quite sure where you got that answer. So that's concerning. But the one person that had 123.79, that person is finding the new price. We've got to understand the difference between discount and sale price. When I'm just asking simply for the discount, or I'm asking simply how much am I going to save, isn't that what we found right there? That's why we called it discount, right? Right?
Right.
Okay? Now, on the test, as you know, I'm now going to give you this question after it. That is when you're going to say, okay, the sale price is after the discount. That is when I'm going to take my original price and I'm going to subtract out that discount to figure out my new price of
23.
but I don't think that was right. Regardless, 123, whatever it was. But you guys can calculate that, okay? 0.75, is that right? Yeah, that's right. Thank you. 123.75. So $123.75. That's the cost that I'm going to have to pay. Now, some of you might say, well, don't we have to pay tax? Yes, you would. You'd have to pay tax on that, but we're not worried about that in this problem. Now, the only thing we didn't get to in this class, guys, we did not get to one of these tax tip questions. We're so much shorter in here. I did them on the other part of the video, so you guys can check that out or check out the Learning Target number 8 video itself. Either way, you can get that practice there. Here, so we were asked to find or to turn that percentage right there into a regular number. Okay. Now, there's a couple ways you could do it, as I've showed you over and over this chapter. The first way, I think many of you are just learning. Here, I'll hit end here and see how we did. The correct answer was 0.042. So 2 of those bars will be correct. Now we got an extra 0 in there, an extra. That person just accidentally hit an 8. Here we got 0.42. This is troubling, guys. We've been doing this for about 2.5 weeks since we came back from school, and yet we are still not getting this. And it's not like you don't get it, like you don't understand it. You just mix up the two, right? You forget whether to go right or go left. That's why I try to tell you, I give you guys other strategies. If that right and left business is what messes with you, if that's what you struggle with, then instead of thinking about it as right and left, go like this. Say, okay, if that were a fraction, what fraction would it be? Yeah. Okay, that's not a good. If I was going to leave a decimal in it, it'd be 4.2 over 100. I know we can't have decimals and fractions. That's fine. But right now, that's what it would be. And then what are all fractions? Division problem. So could you do it that way? And then that helps to remind you that whenever you see a percentage, you know that you have to divide by 100. Guys, there is no way, I hate using the word memorize in math. It's like math isn't a memorized thing, usually. Maybe other classes are, but math usually isn't. Now, when you get to older and you get into high school and stuff, you have to memorize equations and things like that. But it's not. It's all about being able to apply those things. Okay, it's not like, hey, let's memorize these vocab words or let's memorize this whatever you're doing. Okay, we have to understand how to apply it. So you have to be able to just know. You have to memorize it. I hate to say it, but you do. When it's going from percent to regular, you divide by 100. When it's going from regular to percent, we multiply by 100. I mean, it's just something you got to go home and make flashcards, do whatever you got to do to get it. But a lot of practice on this video you can use there. So we're going to divide it by 100, which means we're going to move it 2 places to the left. So we're going to go 1, 2, and then what do we got to add in there? The person that had 0.42 right there, that person only moved it once. We should never just move it one time. Okay? And then the person that had 420, they took 4.2% and multiplied it by 100. They did it backwards. Okay, we've got to correct that. All right, let's go ahead and do this one right here. If we're struggling with any of these type of questions, guys, you got to review Learning Target 2. Okay, you got to do it because you just got to figure it out. You got to get it down. Okay, but this one here, we're trying to figure out what percent 20/25 is. Now, there's 2 ways you could do it. Okay, and we got answers all across the board, which is once again a little concerning. Okay, you could turn it to a regular number by doing all fractions or division problems. That makes it 0.8, right? Then from there, that's a regular. And we know when we're turning it to a percentage, we've got to multiply it by 100. It's going to become 80%. Okay? The other way you could do it is anytime you have a fraction you want to turn it to a percentage, just do your percent proportion. Part over whole equals percent over 100. Cross multiply divide or just times 4 times 4. Either way, you're going to get 80. Everybody understand this? Right here, if there are 440 pieces of Skittles in a bag, how many Skittles did you eat if you ate 25%? The whole strip represents 100%, right? Now, we always want to identify the percentage. That's going to tell us how to cut our strip diagram up. So how should I cut my strip diagram up since that's 25%, Callie? 4 25% sections. Now notice, I'm going to write 25% in here, 25% in here, on every strip, or every part of my strip. Now, do you also agree that this whole strip represents some sort of total? In this case, we're talking about total Skittles, right? So we know that in each part of my strip diagram, I am going to also have to put in a certain amount of Skittles. So now we go back to the question. Really what the question becomes is that number right there a part or a whole? And that's what you need to figure out. So let's do it the way that I've kind of showed you. I'm going to highlight 25%. Now who can tell me? What happened to 25% of the Skittles? Like, give me a label. I don't want to know the number. Nixon?
They're eaten.
They were eaten. So they were
8.
8. Okay? So that means what is the remaining 75%? What's happened to them so far? Callie? They're left over. Good. And then obviously the amount you've eaten plus the amount you have left over, shouldn't that be the total? So what we have to figure out is if 440 is the amount that I've eaten, have left over, or is that the total amount of Skittles that we started with? That's really the question. That's really the only thing that makes this hard and the next step. Tatum. It is the total. So we're given the total. So now we've got to figure out how many Skittles would go into each one of these little parts of my strip diagram. So we look at that and we say, okay, how am I going to figure that out? How am I going to figure out how many Skittles are going to go into each part of my strip diagram? Yes?
I'll use divide 40 divided by 4.
I'm going to do 440 divided by 4. And the reason I'm doing 4 and not 1 or 3 is because this 440 is representing the whole strip, the entire thing, right? So we have to break it down equally. So that's going to put 110 in each one. And then how many did I eat, guys? 110. What should you do at the end? I see a lot of you didn't do it as I'm looking around at boards. What should you do at the end tomorrow on the test? Because why not? If you finish with 20 minutes left in class, why wouldn't you do this? What should you do, Shane? Check with a proportion. So we got part over whole equals percent over 100. Okay, we know 25% goes there. Now I like to put labels. You've heard me talk about labels. What happened to 25% of the Skittles? Reese? They were eaten or ate, whatever the correct word is. There we go, and this will be total. So is 440 a part or a whole? Malia? So there we go. We cross multiply. We divide by 100. That's going to leave us with 110 Skittles. Everybody got that? Yes.
Is the test
It's not. It's on the clickers again.
Yay.
Okay, let's go ahead and go to this one now. Go ahead. Okay, so obviously Mr. Garrison had 60 boys try out for the basketball team. He was only able to keep 75% of them. How many boys that tried out actually made the team? So right here, I know this is going to be 100%, right? And I see 75%, so how am I going to cut up the strip diagram? Yeah? 4 pieces of 25%. Kind of redundant, kind of the same thing over and over again. But 25%, 25%, 25%, 25%. Okay? Now I'm going to go ahead and I'm going to highlight 75%. Or you can do brackets. I don't care how you guys do it. I do both just so you guys can see it. Okay, so I'm going to draw my little bracket on here. There we go. Okay, now, what happened to 75% of the players? Like, what happened to them? Tatum? They made the team. So then what happened to the other 25% over here? Yep. They didn't make it or they got cut, however you want to think about it. They didn't make the team though, right? So now we've got to figure out whether 60 is representing the whole or it's representing this part. That's really what the question comes down to. What is it representing? Did 60 boys make the team, 60 boys get cut from the team, or did 60 kids try out total? This was our 60 total. Okay, so then we're going to do 60 divided by 4 to figure out that would put 15 boys in each one. So that means I cut 15 players, right? And it means that 45 made the team, right? Now, we should check with a proportion, right? We have part over whole equals percent over 100. We have 75%. We know that 75% made the team, so I'll put made. So this must be the actual that made, right? This will be total. Is 60 the total or the part? 60. Cross, multiply, divide, you will get 45. Okay? Here, I'm going to change this. Hold on a second, though. I'm going to change it just a little bit. Go ahead and do it. All right. So the question is, it's one like this. You know you're going to have one like this on the test. I don't know what the answer is, so I'm not going to put it in yet. But we had a lot of different answers there. Okay, you're going to have one just like this. This might not be finish line or shoes, but it might be something like that. Hint, hint. Okay? So what percent of the shipment are dress shoes and football cleats? So if we were doing this one, we would say, okay, this is going to be my part. This is going to be my whole. This is going to be percent over 100, right? Now, we're trying to figure out the percentage. Shh. Sit down. We're trying to figure out the percentage, right, everybody? Okay. That's what we're trying to figure out because it says what percent, right? That kind of makes it pretty easy of what we're going to be doing. Okay. Then it says of the shipment are dress shoes and football cleats and football cleats. So what is this percentage going to be? What's it going to be representing here, guys? Tatum? Dress shoes and football cleats. This is going to be dress shoes and football cleats. See how I'm doing that, guys, with labels? Now, I look up, and then what's my whole going to be? Obviously, it's going to be total, right? All right. So I look up and I say, here's my dress shoes. Here's my football cleats. What do I need to do to those two numbers? Yeah. I need to add them together. That's where I'm going to get what, 44? 44 out of 110. You got to add all these up to get your total amount of shipment. Now, right there it says of the shipment. Of. Doesn't of mean whole, guys? Of the shipment. So now from here we can cross multiply and divide. Now I'll get my calculator out. Is this recording?
No.
Yeah, it is. Okay, I'll get my little calculator here, and I'll just do it for you guys so you can see the rounding of it all. Okay, it's going to be 44 times 100 divided by 110. Oh, it gives us exactly 40. Now, we had a couple people with 44, I think. Maybe they were just looking at this, but yeah, that actually worked out. We didn't have to round it all on that one. It's kind of nice. You will have to round on the summative to the nearest whole percent. So if that would have been 40.951, something like that, we would round right there to the nearest one's place, the nearest whole percent, which would be 41%, right? But that's just if it was. It's not. It's 40%. Okay, guys, let's see how we did on this one. So 96 was the correct answer there. Okay, so let's talk about how we would have found that. We look at it, it says what percent. So obviously you got to do the percent proportion on all these. Part over whole equals percent over 100. Now, what's the two words that help us to identify the part and identify the whole? Callie? Yeah, is helps us identify the part. Of helps us to identify the whole. Okay? What percent is 24 of 25? And that could be written as of 25 is 24 too. It could be written either way on that. But it's all about the is and the of, right? We know that this is what we're trying to figure out right there. And then what's my whole? Is 24, 25 my whole amount, my total? What is my whole? Yeah.
25.
25, good. And then what's my part?
24.
24, that's going to be a 96%, right?
Yeah.
Okay, good. All right. Let's go on here. All right. So this one, you know, you're going to have one just like this on the summative tomorrow. So we have part over whole equals percent over 100. We know that 30%. So I work at Nike. I get a discount. I get an employee discount. You guys know what you're supposed to do? Okay. I get an employee discount. That is 30% off. So what is this 30% representing? The what? What does this represent? The what? Yeah. The discount. So this must be the actual amount of discount. This is the total. This is the total, right? Right?
Yeah.
Okay. So what gets confusing is whether students, do we put 120 there or 120 there? That's what people struggle with. But you've got to remember, whenever we're doing tax, tip, discount, the first step is we have to figure out what 30% of that is. So when you say it, think about it like that, what does the word of tell us that 120 is? The whole. For those of you that put 120 here, you're going to get a number, like a bigger number, and that would be if you were saving $120. Then you'd be finding the new price. But we're not. This was the original price. We always put that in the hole. We're going to cross multiply divide. We're going to get 36. Now, not everybody was in, but I see that somebody put 84 something. Okay. You got to remember, guys. What's the question asking for? The discount. If this is the percent discount, then this has to be the actual discount, the actual amount of money discount. Okay? Everybody got that? Hello?
Yeah.
Okay. So you wouldn't subtract. You wouldn't do 120 minus 36. You wouldn't do that. It's not asking for the new price. It's asking for the discount, how much you are saving. Now, on the summative, you will have this question, obviously. It's going to have this question below it. Well, what is the sale price? Remember, sale price is how much the price for what they're going to cost after the discount. Okay? And what's that going to be? Well, that's when you take 120 and subtract 36 to get $84. Everybody understand that?
Mm-hmm.
So sale price is how much you're going to pay, the price after you pay. The discount is how much off or how much you're saving. Okay? All right. Last one. Right here. Go ahead. Okay. So tax tip question. You know you're going to have one on there? Now it's time to review for it. How many proportions do you need to do? 2 of them. So we have one for our tax, and we're going to have one for our tip. Okay, we know it's just going to be a percent proportion, just like we've been doing, right? Do it the same thing over here. Part over whole equals percent over 100. Now, again, if we're going to use labels, what would this label be? Yep.
Well, wouldn't it be tax?
It would be. And this would be tax. This over here would be tip. This would be the actual tip. Everybody got that? Total food and drinks, total food and drinks, total food and drinks. Just like the Kyrie question we just did, the shoe question, we have to figure out what 7% of that is and 15% of that is. So that's how you remember that that's always going to be the whole amount. So we know this is going to be 7%, this is going to be 15%. Okay, my food bill is going to be $24.93. $24.93. I'll get out my calculator and calculate this. So we have 24.93 times 7 divided by 100. Shoot. There we go. So we get, for this one over here, it's 1.745. 1.745. Now this is where we've got to be really good rounders. We know that money goes to how many places? 2. So this is either going to be what or what? It's either going to be, Nixon?
175,
$1.75, or it's going to be $1.74. What's it going to be?
75.
It's going to be $1.75 because you have to round up because the number to the right of 4 is 5 or more, which we raise the score. Okay, now we'll do 4 or less, we let it rest. 5 or more raise the score. So over here, we'll do the same thing over here. 24.93 times 15 divided by 100. That's going to give us 3739, right? So that's going to be either what or what here, Malia? It's going to be 373 or it's going to be $3.74. What's it going to be, guys? This 3 is going to look to the number to the right, and that is 5 or more, so it's going to go up to 374. Now, over the course of reviewing for this chapter or going over this whole thing, I still see some people that are simply just doing this. They are just adding the tip and the tax together. Bless you, bless you, bless you. Okay? They are just adding the tip and the tax together. That would be great if I could just add those two together, and that would be my total cost. Remember, the total cost, quit packing up, please. The total cost is the cost for the person at the restaurant. So if I'm there, yeah, I do have to pay the tax to the government, right? Yes, I do have to pay the tip to my server. But what else do I have to pay? I have to pay for the food that goes to the restaurant. I have to pay the tax that goes to the government. I have to pay the tip. Now, I saw some people doing this on their formatives and whatnot. I see people adding like this, 24.93 plus 1.75 plus 3. That's fine. If you want to do that, I don't care. That's great. It's practicing an elementary skill. That's great. I have no issue with that. But when you get done, take an extra 10 seconds and check them in your calculator. Okay? Just quickly add them up and check them. What was the correct answer here? $30.42, right?
I did get 42 cents.
Did you round wrong?